Hello! So, now we're going to talk about the case when we end up getting a remainder. So far we've talked about how to factorise this thing and we get a nice set of three factors. Now we're going to talk about the case when we don't get that. Okay, so in other words, what I'm saying there, the question might say, for example, given this polynomial, find the remainder when it's divided by, I don't know, when it's divided by x minus 1. Okay, so let's find the remainder when it's divided by x minus 1. Well, I'm going to use my quick method, right? So I'm going to use my synthetic division. So what I'm going to do is I'm going to use the root. Okay, so set up my synthetic division, little upside down division thing. Okay, first of all, I'm going to find the root. So if x minus 1 is the factor, then the root is 1, x equals 1. Okay, then I just use the coefficients of this thing here. So I've got 1, I've got minus 3, I've got minus 6, and I've got minus 2. Okay, put another line in there. And remember, when I move down, I add. When I move kind of diagonally across, diagonally across that way, I multiply. So 1 plus 0, that's just 1, okay? And then I move across, so I'm doing 1 multiplied by my negative, by my 1 up here. So 1 times 1 is just 1, and then I just add when I'm moving down. So minus 3 plus 1. Minus 2, move across, minus 2 times 1, that's going to give me my minus 2. I'm moving down, so I add, so minus 6 minus 2, that's going to give me minus 8. And then I move across, that's minus 8 up here. Minus 2 minus 8, that's going to give me minus 10. Okay, so let's have a look. So I've got x squared minus 2x minus 8, and my remainder is my minus 10. Okay, so how can I express that thing? Well, what did I start off with originally? I started off with x cubed minus 3x squared minus 6x minus 2, all divided by x minus 1. Okay, and I've just said that that is all equal to x squared minus 2x minus 8. So x squared minus 2x minus 8, then I've got a remainder of minus 10. So the way which I can write that is minus 10 out of my x minus 1. Because let's just think about that. Let's suppose I had, I don't know, let's suppose I had 5 and I wanted to divide it by 2, okay? That would be equal to 2 remainder 1, okay? Remainder 1. Or I could express that as 1 out of the 2 left over, so 2.5, okay? So that's all I'm basically saying there. It's like 2 plus a half, okay? So I get 2 whole ones out and I have half left over. So that's all I'm basically saying. I've got minus 10 out of my x plus 1 left over. That's all my last thing is saying. Okay, but I'm actually going to rewrite that slightly. I'm going to now multiply through by x minus 1. Okay, so that's now effectively what I've got. And the reason why I want to write it like this is because I want to show you how the remainder theorem actually works. So the factor theorem is basically saying when I stick a number in here, and if it equals 0, then it's a factor. The remainder theorem, though, is basically saying when I stick a number into this thing here, if it doesn't equal 0, then whatever it equals is my remainder. Why should that equal that? So let's suppose I put in, I don't know, let's suppose I put in f of 1. Okay, f of 1. So I use that basically. I say, find the remainder when it's divided by x minus 1. So I put the root in, I put 1 in, okay, and basically look what happens here. So I get x minus 1, so 1 minus 1, times by whatever goes in here, minus 10. But look, because I've got a minus 1 minus 1 going on there, that thing's going to equal 0. So that's going to go to 0, which means that all of that first thing, all of this thing in here, is all going to go to 0. So that's all going to equal 0, it's all going to disappear. So f of 1 is going to give me my remainder of minus 10. That's the reason why it works. So basically, if the question was saying, find the remainder when this thing here was divided by x minus 1, okay, I'd basically say, well, let's put 1 into this thing, okay, see what happens, it all disappears, I end up with my minus 10 there.